All right, hello. Okay, so team getting this Elmo working. I hate that too. Come here, Elmo. Okay, there we go. All right, everybody. So this lesson is about similar figures again, and today we are proving if triangles are similar. We've done this before with congruent triangles. Now we're doing it with similar. Right. So let's start with the vocab. Corresponding means matching. Proportional means equal. Ratios. Similar figures are when corresponding angles are congruent. Okay, corresponding angles are congruent, and we see that in with these marks. Saying all three sets of angles are congruent there. Let's check one. Okay, and then corresponding sides are proportional. Meaning, if we compare 6 to 12, that's times 2, right? I'll do 12 over 6 equals 2, right? 16 over 8 is also 2. And then 18 to 9 is also 2. Sorry, I'm going to mess up. So that means that sides are proportional. Okay? Now, that's better for you. Okay, so you can see corresponding angles are congruent with the purple congruency marks, and then corresponding sides are proportional because I divided 12 by 6, 16 by 8, 18 by 9, I got 9, the same number 2. And that number that I got is your scale factor. That's your ratio of your corresponding sides. Right? So scale factor is everything I did in blue here. That 2 to 1 ratio. I think this triangle is twice as big as this one, or this one is half as big as that one. Okay? Now, when triangles are similar, we have a similarity statement, right? Where we name one triangle, so I'll name this FEG. And then we use the similarity squiggle to say it's similar to F goes with Q, E goes with P, and G goes with R. Okay? And we're going to get back to our congruence postulates that are congruent. So those were, remember, SSS, side, 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 angle, side, angle, side, angle, 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 side, and H. Right? So we're going to do next. We're going to see some triangles. We're going to see if the triangles end up being congruent using the information I am giving you. Okay? And so we're not going to check all three angles being congruent and all three pairs of sides being proportional. Instead, we're going to see if I give you less information than that, do the triangles still end up being similar? Right? So start with two triangles where they have two sides and the angle in between them. Okay? So that is a set of triangles that look like this. Right? I got two sides here and here, and I'm noticing that these two triangles even look similar. Do, right? They're not the same size, but they are the same shape, right? This just looks like a shrunken version of that triangle. They're still the same shape triangle, right? Now, when I look at the two sides, is there proportion going on? Yeah. 2.5 times 5 gives me 5. 1 times 2 gives me 2. So these sides are proportional, and then the angle included between those two sides is the same. That they're there. Yep. When we got this going on, if the angles are congruent, are the sides proportional? Yep. End up with similar triangles. Okay? That's called the side angle side theorem. Triangles are similar if the ratio of two sets of corresponding sides are proportional and the angle included between them are congruent. So, in the picture, for example, okay, if in this picture we got A congruent to D, okay, see that here with the congruence. Now, if the side here and here include angle B and D, ends up being that we have AB divided by DE. So this side divided by that side, if it ends up equal to whatever AC over DF is, then those two triangles are going to be similar. I get to write it in the statement. Notice I have to put the two sides, make the congruent angle in between them. Okay? So look at example 3, and if I want to know are the triangles similar, so how do you know? Well, I'm noticing, first of all, that congruent angle again. I'm noticing a 90-degree angle, so that's congruent. Okay, so when I look at my from here, that's the angle in between. Then let's compare 2.3 over 1.5. 2.3 divided by 1.15. What does that give us? 2.3 divided by 1.15 is 2. Okay? And then let's divide another 4. 4 over 2 is, okay, so the scale factor is the same, so those sides are proportional. So yes, are they similar? Yup. By the side angle side similarity. Okay. Let's jump to another one. So this one, I'm going to get two, right? And let's see what happens with the two triangles. I have a set of triangles here where two angles are the same, 59 and 86, right? 86. Now, do these triangles look similar? Yeah, they are. Look, they seem to be the exact same shape. One of these triangles isn't like good in relationship to the other one, right? And notice even just the two angles, I get to know the third angle is being the same. They all have to add up to 180 anyway. So, yeah. So with this one, our angles are congruent, those sides are proportional. Yeah. So yes, it's improved similarity. So angle. Opposite. Told it this one. Okay. The angle postulate, okay? So basically it says triangles are similar if two set corresponding angles are congruent. So in this picture, I notice A is congruent to T, B is congruent to E, right? So A is congruent to D, angle B is congruent to E. Therefore, I get to say my triangles are congruent. Or sorry, not congruent, similar. Okay? So if we look at example 1, are the triangles similar? Well, how do you know? Well, when I look at the picture, see what I got going on. I see that both are 90-degree angles, so those angles are, I see particular here and here. Yup, they two sets of corresponding angles congruent, so yes. I can say by angle. We're going to jump to the side. What happens if I have two triangles where basically sides all proportional, okay? And it's hard to, these are flipped over. Basically, we can kind of see here already that they look to be similar. This just looks like a shrunken version of this triangle. Those are like entirely different shapes. Let's see other sides. So 5 to 10 is a scale factor of 2. It's like this, you guys. My bad. Okay. So, yep, 5 to 10 is a scale factor of 2. Triangles are like this is supposed to be a 4. This is not supposed to be. That makes more sense. Okay. So 10 is a scale factor of 2. 8 to 4 or 8 is a scale factor of 2. Then 3 to 6 is a scale factor of 2. So the sides are proportional, and then look what happens to the angle. 3 angles are congruent. Yeah, that actually meets the criteria of similarity. Right, where angles are congruent, sides are proportional, so we end up with 2 similar figures. So it's the side theorem. It says triangles are similar if the ratio of all 3 sets of corresponding sides are proportional. Remember, that means equal ratios or same scale factor. So basically, how to get a triangle? If AB over D, I divide those, and then I divide BC over EF. And then if I divide AC over DF, and if that all ends up being the same quantity, then I say those 2 triangles and other sides are. Again, you can say that with going there. So if I look at example 2, I want to know, are the triangles similar? So how do you know? Well, let's compare. I'm noticing we get 3 side lengths. I'm not giving any angles. Let's see what's going on with the first lengths. So I'll start with the smallest side. The smallest side goes with the smallest side over here. We divide 88 by 40 and see what I get. I'm going to be dividing 88 by 40 right now. Got my scale factor, and that equals 2 points. Okay, now let's compare on the middle side length. So that's 3, and then that's 110. Okay, so middle, it's basically 110. See what I get? Also gives me 2.2. And then let's compare that last largest side length. So 143 over 65. Okay. 2.2. So, are these triangles similar? Yep. They are. Side. Similarity. Okay. And that's it. Hope that made